Hello, and welcome to my project, The Green Titan. This journey started from a combination of personal interest, a school class requirement, and a pivotal project marking the culmination of my high school journey, and I'm excited to finally be able to share my journey with you. The Green Titan is an automated model roller coaster that I started in the summer of 2022 and finished it nearly a year later. I've dedicated a substantial amount of time to this project, investing a minimum of several hundred hours. In the context of my high school graduation requirements, I was tasked with creating a project that involves working with mentors from the community, expanding my knowledge, and producing a tangible final product. This product would then be presented to a small review board at the end of the first semester. As I worked on this project, I also integrated it into an independent research class I was taking at the time. This strategic approach allowed me to manage my time effectively and optimize my efforts as I pushed the boundaries of what I could achieve. I've had a clear vision of working on a 3D printing and automation project for a while. Being a passionate roller coaster enthusiast for about 6 years and having aspirations to pursue engineering in my upcoming school endeavors, I saw an opportunity to merge these interests. I had previously come across some remarkable creations on the internet which served as an inspiration for me to embark on my own adventure. To be honest, this wasn't my first attempt. Approximately 3 years ago, I started experimenting with 3D printing at my local library. My initial project involved creating a piece of roller coaster track, but it turned out to be of poor quality and didn't meet my expectations. I soon realized that I had underestimated the complexity of this task. Around a year later, I summoned the determination to try again, armed with a different idea and renewed sense of enthusiasm. However, I faced setbacks once more. It wasn't until I visited Universal Studios Orlando shortly before learning about this project that my creative spark was rekindled. It was during that trip that I had a breakthrough and finally grasped how to successfully accomplish my roller coaster automation project. The model itself is designed to mimic the automated roller coasters that tens of thousands of people enjoy daily. It incorporates a comprehensive collision avoidance system that demonstrates safety through the use of various sensors, logic programming, and is powered by an Arduino controller board that oversees the safety features, brakes, and the lift mechanisms. The roller coaster trains are sourced from Kinect's toy sets, which I've been using since my childhood. I've tailored the track dimensions to ensure the smoothest operation possible for these trains as I could at the time. The entire track structure and its supports have been custom designed by me and manufactured through 3D printing, utilizing both my personal 3D printer and one available at my school. The automation system relies on small Hall effect sensors to detect the presence of the trains. These sensors can detect magnetic fields generated by small magnets that I've affixed to the train specifically for this purpose. As a result, there are constantly 3 trains circulating along the track layout, all safely safeguarded by the same safety system. This project, as much as I love it, is not perfect. Some notable issues have emerged in the course of this project. These include challenges with optimizing and fine-tuning the code, achieving consistent lift positioning, and maintaining a neat and organized system. As I reached the final stages, I recognized the potential for slight improvements in the coaster's speed of operation if I could overcome some hurdles, but ultimately I ran out of time before the school year ended. One significant lesson I've learned relates to the sections of track where the elevator picks up and drops off the coaster's train. The tolerance levels of the support structure need to be more precise, and the supports should be denser to enhance stability. During the loading and unloading process, any shifts in the table or bumps to the structure could displace the track connections just enough to cause the coaster to fail in fully loading or unloading the train, leading to a safe but unintended stoppage. First off, I would like to thank my wonderful family for supporting me all the way through this, and especially my parents for sparking my love for engineering in my childhood. Then, to the best science teachers who aided me along the way, whether in ideas, feasibility, and general support that got me here today, thank you, Mr. Lineweber and Mr. Perry. To the 2 engineers at Endress and Hauser, TJ and Trevor, for building the supports of my ideas all the way back when I first brought it up to them, thank you. And finally, my friends at work and school who were there for me all the way, thanks everybody. Before this project, I made a really crappy RC car before I knew what I do now, but was happy with it being my first 3D printed project that came together before this one and was pleased by a huge learning opportunity. Moving forward with my free time around college and work, I've got some other ideas I want to work on too, like more RC vehicles such as planes, drones, ground effect vehicles, and autonomous crafts too. Lots of these will be new learning opportunities for me, and hopefully fun ones at that. Adding on to that, I also want to increase my production quality for the future videos. I borrowed this camera from Mr. Lineweber in his class, but I want to be able to edit, film, and make it all flow so much better in the future and have fun with this channel. Planning would help too, as I'd lost access to this coaster months ago once I graduated and have been stuck with these certain numbers of clips since I previously filmed them. If you've watched this video to this point, I very much appreciate your time and hope you enjoyed the video. Now, onto the fun bloopers.
See that red thing comes up?
Yeah, I do see that.
Oh, that's tappy. Oh, you were?
Yeah, it's fine.
Oh, you're not.
I'll put it at the end of the video.